Before we dive into our new graph, let's have a quick recap of what we know about all the simple functions. For example, the linear function. Look at the graph. We have the form y equal to a, where a is a constant number. These create horizontal lines that are perfectly flat, no slope, no curve, just a straight line across. You see the blue line at y equal to 3. No matter what x value you choose, whether it's -2, 0 or 10, your y value is always 3. It's just like a perfectly level table. The orange line at y equal to minus 0.5 works exactly the same way, it's just positioned below the x-axis. These horizontal lines are going to be a reference point in the future. When we start looking at cubic, reciprocal, and exponential graph, you will see the graph curving and bending. But remember to compare them to the straight, simple horizontal lines as a reference. Now let's add another layer to our foundation. You can see that we move from constant function to linear function. And notice now the graph has started to become kind of more alive. The form y equal to ax shows us that linear function that pass through the origin. Here a is our gradient or slope, and it tells us how steep our line is and which direction it's heading to. Look at the red line, y equal to 2x. It has a positive gradient of 2, which means that it's climbing upwards. For every one step we could move right, we go up 2 steps. It's a climbing stairs. The rate is steady, predictable, and the rate of change is constant. The blue line y equal to minus 0.5x does opposite. With a negative gradient, it's descending as we move from left to right. For every 2 steps right, we go down 1 step. Here's the key insight. Both lines will pass through the origin. This is because when x equal to 0, y will also equal to 0 in the form y equal to ax. And also notice that these are still perfectly straight lines. The rate of change does not vary. Whether you are at x equal to -5 or x equal to 10, the gradient, which we'll learn later, you just look at the slope of the line, they stay exactly the same. This is going to change when we meet our new function, cubic function, reciprocal function, and exponential function. Now see what happens if we add just the latest superscript 2 to our equation. We go from y equal to ax to y equal to ax squared, and suddenly our perfectly straight line have transformed into curve. These are called quadratic function, and they create what we call parabola. Notice how dramatically different this looks from anything else we see before. The straight line world no longer exists. Now we have curve. Look at the green curve, y equal to 2x squared. It's an upward opening parabola that passes through our origin, just our linear function. You see how it starts nearly almost flat when it's 0, and then rapidly accelerates upwards. As x equal to 1, y is only 2, but x equal to 2, y jump to 8. The rate of change is constantly increasing. The purple line y equal to 0 minus 0.5x squared does something fascinating. It opens downward, creating a mountain-like shape. It has a maximum point at the origin and then fall away on both sides. This kind of shows us acceleration and deceleration. Whereas linear function give us constant speed, quadratic function shows us what happens when we try to speed things up or slow down. Think about it. When you drop a ball, it doesn't fall at constant speed like a linear function. It will accelerate due to gravity, kind of following a quadratic path. When you throw a basketball, the arc through the air, that's a parabola. This curve are everywhere in the real world: satellite dishes, car headlights, the cables on suspension bridge, and even the path of water from a fountain.
Smash your maths exams. Download Learn Maths Today for real exam questions and achieve top marks.